at least on the first two. All right, Alondra, can you do 4A? You're in group 1.
Yeah. Well, I just did the X a negative.
Uh-huh.
And then I like put it in the other X too.
Okay.
And then that made it a negative 2x like fifth and then minus 1. So I put it's neither even nor odd.
Okay. And how do we know it's neither from this? Like, what of this tells me that it's neither?
Because it doesn't, or I think it's because it doesn't equal like f, like positive x, right?
Well, if it's even, it would equal exactly the same thing as the original. And it's not even because it's different, right? We have a -2 instead of a +2.
Yes.
And if it was odd, what would it look like?
Oh, like the opposite.
Yeah, we would have changed all the signs. So it would have been a -2x to the 5th plus 1. And we don't have a +1. We have a -1. Okay. All right. Thank you. And Brian for B.
I was working on number 1 instead of number 4 because I'm an idiot. So give me a second.
Okay.
I'm still working on it.
Okay.
If you want to come back, I guess.
All right, I can come back to you. Kathleen, can you do number 2 or B? Can you do B?
Yeah, I put it in with the negative x as well, and I said that it was even
Because why? Why is it even?
because they're opposite.
They're opposites? What are opposites?
Like the sign when it's flipped, it should be opposite, right?
The signs are the same, I think, right? Isn't the original a +2x plus 5? And our
Yeah, I'm sorry. No, it is. Yeah.
Okay, yeah. So since it's the same, it's even.
Yes. Yes.
Okay. All right. So let's see, Vanessa for T.
I plugged in the negative and got odd for that one.
Okay. So the signs were flipped, right?
Yeah.
Okay, so that one's odd. Okay. All right, Jerry for letter D.
I put even.
How did you get that?
I wasn't sure how to solve it. So I look at the exponent to the exponent of 2. And then it has a +2, and I assume that would be even. I just matched it with something else that was even on my notes. I was trying to figure out how to solve it.
Can you look at what we did for A, B, and C and try to guess kind of what we would do?
Yeah.
Process.
So you put -x inside the red parentheses.
Uh-huh.
So
And then we
you
also put it here.
yeah, so then
Okay.
+2. And then that'd be x.
Still square root, right?
Yeah. And then it'd be x +2.
X squared still, right? Because -x squared is still x squared.
Yeah. So that makes it even.
Yeah, because it matches the original. Okay. Nice. Cool. All right, let's go on to number 5.
I have a question.
Uh-huh.
I just want to confirm, because like I end up getting the right answers and stuff, but at first I had got stuck. So but my question is, if I have what I know that I need to change the x into a negative to determine if it's but when I was looking at the x, just saying, okay, I could use number A as an example, how it has 2x to the 5th. And then, when I changed that x into a negative, it spit out -2x to the 5th. But if the exponent was a 6, that would have changed it back to positive.
Yes.
Okay, yeah, because that's why I'm kind of getting confused that like you know, like with my whole exponent, like a x times a negative x is, you know,
Mhm.
yeah. I just trying to confirm that.
Yeah, you got it. Yeah, odd exponents kick the negative out, and then even exponents get rid of it, right? It has to do with how many we have. So if we're looking at negative x to the 5th, that means I have 1, 2, 3, 4, 5. So these two will become positive x squared, right? These two will become positive x squared, and then we still have a negative x squared there. So when I put all that together, I get negative x to the 5th. There's still a negative there. You have to have an even number of negatives for them to all go away, for them to all cancel.
Okay, thank you so much.
Mhm. All right, number 5, we are at Fidel.
5 should be odd
Why?
because it's bouncing off the X, right?
Oh, are you thinking about multiplicity?
Oh, okay, yeah.
Yeah, multiplicity has to do with whether it goes through or bounces back.
Hmm.
But this is just asking if the entire function is odd, even, or positive, or odd, even, or neither.
These are asking for symmetry too, like, because we talk about even and odd symmetries, and then we talk about even degree and odd degree, and those are different things.
Does that help you get started on that one, Fidel?
Not really, to be honest.
I can try my luck at this one.
Okay.
I thought it was neither,
Okay. Why is it neither?
because there's no symmetry over the y-axis.
Okay. So that means if we fold it like a book, right, that both sides don't match. Okay. And
Oh goodness, what was the other part? I just kind of looked at all three of them and did my best guess, most likely.
does anyone remember the other symmetry besides the
You
y-axis?
can
It's not on the
rotate
origin.
it 100.
Yeah. Rotational symmetry, right? So you
Yeah,
can rotate it.
180 degrees.
Yep. So if I spin that, if this is a piece of paper and I put my pencil right here, right? Like here's my pencil, my eraser, and I put my pencil right there, and then I spin my paper 180 degrees, it's not gonna match. So it's not odd.
There used to be a way to flip the screen, and I know there used to be a way to flip the screen on your computer because we did it to annoy my computer science teacher when I was in high school.
When I used to teach this in person, I would use patty paper. It's like the see-through paper. And I draw the function and then hold the pencil in the middle and then turn it and see if it works so the students could see. So that's basically what you're imagining. If I turn it 180 degrees, it's not going to match. So let's see. Let's go back to Fidel. Fidel, does that help you answer B?
So if you rotate it, it does match. So
it's which one? Odd or even?
it would be even.
Odd is rotating. Even is the book.
Oh, okay, got it.
Yeah. All right, so Ganya, we're at you for C, 5C.
You want to say is even
Even. And why is it even?
because of the symmetry on the y axis.
Yep, good, awesome. All right, so since some people did not finish number 6, I'll send y'all back and we'll do 6 and then I'll add some more problems too. So we'll,
Actually, excuse me, I would like if we can do number 2 after we finish our this for 5, 6, please.
well, we're gonna go through the problems that I picked out and then we can go back to 2 if we have time.
Yes, please. I'm just asking if it's possible. Thank you.
Yeah, so we're gonna do 6 And then we were going to do, which other one did I picked out? Trying to pick out ones that I think are super useful. 9. We don't have time for everything. And let's go to 10. So let's do those 3. And if you've already done 6, then you just go to 9 and 10.
We'll try. For 6A, I got even.
Okay. Why do you have even?
I guess this about, I don't know, 6 different times changed my answer. And I finally just got some graph paper and graphed out those points to see how they actually looked. And now I lost it.
And it looked even?
Back to
1, 2, 3, 4. 1, 2, 3. Wait, 1, 2, and then negative or positive 3. So it looked, oh, whoops, that's not very good. Move that up a little more.
it looks like if you fold it or spin it either way, it's gonna balance out.
Oh, interesting. So it's both?
It certainly looks that way.
Huh. Okay. So then we have 2, negative 3, and then we had 4, negative 1. Okay, so if I connect it, looks like that. So if I fold it over the y-axis, so if I fold it right here, this point's gonna go over here. That's not gonna match the other side. Right? And then this little hill is gonna go over here. Like it's not gonna match for even. Even's not gonna work.
Let's see what I did there. All right. So I guess that would make it odd.
Mhm. Yeah, if I spin these points 180, it should land over here. So it should be odd. Is that what everyone else got? Is it odd?
Yeah.
Yeah. Okay. If you're not sure, you can always graph it like Michael was suggesting. It's a good plan. All right. Next is Ashley for B.
For B, I had got neither.
Okay. Why is it neither?
The reason why I had got neither. I'm gonna keep it real. I did process, I'm not gonna say I did process of elimination, but I know one of them was odd and the other was even. So I was like, I know the one that, the one that didn't have one was neither.
Okay.
I know, because I know how to understand how to get the odd and I know how to understand to get the even.
Mhm.
So, but I couldn't remember how to get the neither.
Well, usually if it's not those, then it's neither.
That's what I was kind of looking at. I was like, I was looking at the even. I'm like, okay, I could pinpoint that was even. Then I looked at the odd, I could pinpoint that was odd. So I was like, those then went. So I said neither, but that's the reason why I said neither.
Okay. Did anyone else have anything else to add? Do you also think it's neither?
I agree also because when I grabbed it, it's just kind of a check mark, like it's not any kind of symmetrical whatsoever.
Okay.
Got
Anyone else?
odd
You got odd?
for 6B.
Mm-hmm. So why do you think it's odd?
Because the points are like on either side of the 0 are like opposite of each other. The same number, just different signs.
So Josh was countering you, Ashley, and saying that it's odd. So what makes you think it's not odd? Because you said it's not odd. So let's try to narrow that down.
Okay, the reason is because, let me see. Because the 0,1 for the odd, it went like through 0, 0, but the 0,1 was 0 and 1. That what made me say I know it's not odd.
And visually, that's because when I spin it, right? Remember, I'm putting my pencil tip here, and I'm using that to spin my paper. So that's going to make it land down here, right?
Mhm.
But there's no 0, -1 on the table. So it's not going to be odd, because if I spin it, it's going to land 0, -1, but I don't have a 0, -1.
Do odds always land on the 0, 0? The origin?
You always spin on the 0, 0 for odd.
Okay.
Yep, that's
I
where
see
your
it.
pencil goes. Now, if you were saying I can put my pencil here, then yeah, you could put your pencil there and spin it, but that's not what odd is. Odd has got to be on the origin. Yeah. Okay. All right, so that one is neither. Okay.
There's two things you gotta check with the odd. They're opposite and they go through the origin, and they both begin with an O.
Yep. Opposite origin odd. Opposite origin odd. All right, next is Carson.
For this one, I got even
Okay, why is it even?
because the Y's along the bottom are all the same sign. They never change.
So this could be like a 3 and this could be like an 18 and it would still be even?
No.
Oh, okay. So not just the sign, what else?
Oh,
Because you said
I
the
wasn't
sign
thinking-
never change.
oh, I'm not sure. I only knew how to go about it like by using the sign.
So, but if you're saying the sign, then doesn't that mean this could be like a 5 and it's still positive?
Yes.
So it's more than just the sign, right? It's the numbers have to match too.
Oh, yes. Yes.
Sign and numbers, yeah, okay.
Okay.
All right, awesome, cool. Let's look at 9. All right, who gets to do this one? Diana, you're next.
So I had to find the local max and min, right?
Uh-huh.
I wasn't really sure about it, but for local max, I got 1 and 3.
Okay, can we write them as a point? Like what's this point? It's -3, you said? Comma what?
1.
1, okay.
And then 1,3.
Yeah, I'd probably say it's a little less than 1, probably like 0.8, comma 3, because 1 is a little bit more over. And these are local max, so I'll write max over them so you don't get them confused. And I'll use blue for the minimums. So what were our minimums?
Is that like a 1.5, a negative 1.5?
Yeah, Negative 1.5, comma.
Negative 1.
And that's our local min. Any others?
0,3.
Other way. 3 is the x.
Mm.
So 3,0. That's our other local min. Do we have any absolute max or mins?
I wasn't sure about the absolute.
Okay.
I only got the max and min.
Okay. Does anyone want to help with the absolute?
I want to go a little bit back, teacher, please.
Okay.
Here we mean like our minima here, we have -1, 1, and this one for the 3, 0 is the minima too, right? Is the local -1,
1.
For the absolute minima.
We haven't done the absolute minimum yet.
No, it's not absolute minima. For the local minima, sorry.
The local minimum was -1.5, comma -1. And then also there's another local minimum at 3, 0.
This one, we consider this one too is a minima, right?
They're both local minimums, yes. minima.
Yeah, perfect. Okay.
All right, anyone want to help with the absolute max and min?
Yes.
There
I can.
isn't one. There isn't one because there's an it.
Eight.
It's like infinite. There's no.
So
We
there's
have
no,
we have a minimum, not a max for the absolute.
okay. So it sounds like we don't have one, but we have the other. So let's clarify more. Which
Sorry,
one
you
do
were
we-
asking for the absolute maximum.
And min together. So which one do we
Oh.
not have? That way I know which one you're talking about.
We don't have an absolute maximum,
Okay, good.
and the absolute minimum, sorry, is -4.
We need that as a point. Don't we write those as points?
Yeah.
Yes.
So what's the absolute minima as a point?
-4.
Well, it's a little more than -4 on the x-axis, I think.
Oh,
I did
it looks like
4.5.
negative. Yeah, -4.54.
Okay, -4. Yeah. Okay.
Teacher,
Negative
you want to
4.5.
ask, excuse me, you want us to write them as a point when we have a test, when we are going to have a test?
Yeah, isn't that how you have them do it also, Professor Sievers? I usually do it as points.
For the min and max, no, I just the F value.
They don't have to write it as a point?
No,
Okay,
if you're referring to the min and max, it's just the min and max of the function.
okay.
With the weight values, right?
Yeah.
Okay. because
So
then-
you want them to list it out with commas, or do you want them to list it in set notation, or just?
Yeah, I mean,
write-
commas are set notation, either one's fine.
Okay, but points are also good, right? That's how I usually have them do it.
Okay.
Yeah,
We'll
that's
with them
that's
both.
fine if you're teaching it that way. Yeah, that's fine.
So like,
Uh,
if you wanted to write it as local maxima like this, you could say 1,3, I guess. Don't put it as a point though. Don't put parentheses around those.
No,
Yeah,
I lost points.
yeah, you're not the only one.
I was
So
upset.
local minima would be -1 and 0. And then absolute, if you wanted to write it this way also. Absolute minima would be -4, and then there's no absolute maximum. Okay. So that's another way to do it.
I did have a question for when we do take the test tomorrow.
Uh-huh.
With the absolute minimum, it was like a 4.5. I had put a 4.6. Is there like discretion on it's
Yeah.
close enough?
Yeah.
Because it's an approximation. Okay.
If you put -4, I would not be happy with that because it's clearly not -4.
Gotcha.
but, Yeah. As your point, yeah. Okay. All right, let's keep going on to number 10. We zoom back out. Okay, who is next? We are at Jade. Jade for 10A.
Okay. So it's asking for the minimum, but there's not like an absolute minimum. So does it just want me to go off like the lowest point there?
It says minimum degree,
Okay.
not local min or absolute min. What's local, minimum degree?
I have no idea.
Okay, can anyone help Jade with minimum degree?
Can you hear me?
Yep, I can hear you.
Okay. I had put on my paper, I had put a point at like where the graph dips.
Okay.
And then I put another point there. Yep. So I had so I know it was 4, and then I did +1.
What is 4? You said it is 4. What is that?
The degree.
There's 4 turning points, right?
Okay. I'm like, I didn't know the name of it.
So the degree is?
It would be 5.
5, yeah. 4 + 1, so it's 5.
I
Okay.
forgot. We literally went over this yesterday with me in front of the class again about what the degree was. Sorry.
It's okay. Yeah, that just means you gotta study it some more.
Okay, and with that being said, like on my paper, I just did 4 + 1 and it was 5, and I picked 5 degrees. Do I need to pick turning points? What I need, you know what I'm saying?
I'm just writing that for people who are taking notes so they understand where we got the 4 and how we got the 5.
Okay.
Yeah.
So the degree is the amount of turning points plus 1.
Yep.
Gotcha.
How come yesterday we were adding the degrees together?
Adding degrees together?
Yeah, like so you know how that very bottom point, it does like a loop up, so that'd be a 2. And then if you go up, there's a degree 3 and there's a 2 again.
That's
then-
for your, that's for if it goes through the 0, if it goes to the axis.
That's when you add them together.
Then we have multiplicities with the 0 and we have to account for each 0. This, they're just telling you to look at the curves and guess from the curves.
Oh, okay.
So this is like the curves plus 1 thing.
Yeah. All right. So B, oh wait, we didn't finish this. Jade, do you know what the leading coefficient is, if it's positive or negative?
Positive?
Well,
50-50 chance here, so I'm guessing either way, honestly.
so remember, if it's even, then they both match, like in a smiley face, and you get your plus.
Oh, and
If
if it's
odd, then they don't, they both go down, right? And that's how you get your sad face, your nose. So they don't match, so we got to use the odd stuff. That's these are even, right? These are even. So if it's odd and we start down and up, is that a positive leading coefficient or a negative leading coefficient?
negative.
That one's positive. And if it's flipped where it goes, starts coming down first like this, then it's negative. So those are the directions for odd. So what would this one be?
Negative.
Negative, right? It's odd and it's negative. Yep. And we know it's odd because it's degree 5. So that kind of helps too. So this should have a negative leading coefficient.
Sometimes, teacher, we can find it as an odd number, but it's positive leading coefficient.
Oh, yeah, but I was talking about which of the 2 options to look at,
Yes,
the smiley face,
yeah.
the sad face, or the opposite ways.
Okay, because sometimes it can be positive with yeah,
Yeah, I was just saying which one to look at. Yeah.
no problem.
All right, B, we are at Joshua, you're at B.
Is it a minimum degree of 4? And then the sign is positive.
Yep, because it's the happy face, right? Here's my little eyes and the plus for the nose, happy face. So leading coefficient is positive. I don't want to write it all out. You can write it. Leading coefficient is positive. All right, and those are all the ones we have done so far. So let's keep looking. I definitely want y'all to do a piecewise today. I know those are your favorite.
I'm sorry, where did the 4 come from?
3 turns, turning points. There's
Oh, okay, yeah.
plus 1. Yep.
Mhm.
All right. Any other questions? No? Okay, so as I said, I really want y'all to do a piecewise. So that looks like number 12 is a piecewise. So we can definitely go to our groups and do that one. That's going to take a bit of time. I hope y'all have some graph paper to make that look pretty, make it look nice and easy to read. I think we'll just do 12 for now and then come back from there. And then I'll give you more to do. So let's go back to groups because that one's going to take a little bit of time to graph. How was it?
I feel like I did something completely wrong.
Uh-oh. Sometimes you feel like that and you did it right though, so we'll see. Sometimes that happens where we think we did it wrong, but we actually did it right. It just depends. All right, everybody else? How'd it go? No other responses. Does that mean it went well? It went bad? If I was a mind reader, I would be very wealthy right now.
Not sure.
Yeah, I
Um,
got through it.
From
on
what
the-
I got in the back for the answers is not a match.
Uh-oh. Other people, did anyone do it and have it match the back?
I also had some issues with it.
Okay. All right. So table is how I always recommend you do it. You don't have to use a table. You can totally do it in your head. I just recommend a table because I feel like it's nice and organized and clean. So for the first part, we have X and then all of our Y's are just a -2. So those are kind of boring. We have -3, must be a -2, all the way to -1 is a -2. And again, I'm going to put a note here that this is supposed to be an open circle unless it happens to match the next table. -2 is also a -2. So that first part's kind of boring, just lots of -2s. So let me graph it. 1, 2, 3, 1, 2. So it's just a straight line, or straight line, they're all lines are straight. It's just a horizontal line. Going like that. Are we okay with that piece?
Yes, I got there.
All right, let's try the next one. Before we even do any table stuff, what does an x squared look like?
Parabola.
A parabola. Yep. So we should be expecting a U of some kind of curvy thing. We should not be expecting a line. It should be curvy. So x and x squared -3. So I'm going to plug in my -1. -1 squared -3 is
-2.
Oh, look, it matches. So it's not going to be open. It's going to be closed. Cool. All right. And then we're going to keep going all the way to 2. So I like to just do whole numbers because I feel like it makes life easier. So 0 squared -3 is -3. 1 squared -3 is also a -2. And then 2 squared -3 is a 1, but that I'm going to write a note that that's going to be an open circle as well, unless it happens to match the next one. All right. So I'm going to graph that one. So we have 0, -3, that's here. 1, -2. Oh, there's my U. You can kind of see it already. Oh, oops, I was an open circle, unless it matches the next one. So I can kind of see that parabola that's formed. Are we okay with that piece?
Yes.
Okay. All right, now let's do our last table. Our last table also seems kind of boring because it just has -1. So it's kind of boring. 2, 3, 4, -1, -1, -1. And that one does not match. So good thing I left that circle open because it's going to go down here, closed. And let me draw it across. Okay, there we go. So that's what it looks like. I know my points are obnoxiously large. Sorry about that. That's what happens when you write an iPad. Okay. All right, so any questions on graphing it? No? Okay, so let's answer A. What's the domain? Domain is x's. So tell me all the x's that we can have.
-1, 4.
We can go all the way from -3, right? With the square bracket. Remember that from like the first week? So long ago. Comma. And then what's the highest, largest x we can have?
4.
A 4. And that's also a bracket, right? Because it's equal to. It's a closed circle. Okay.
You said it's a bracket and -3 and closing 4.
They're both brackets. They're both closed.
They're both brackets,
Yeah,
yes.
there, and that means closed circle. Same thing.
Okay.
All right. For C, we already graphed it. B, evaluate f of 0. So what's f of 0? We already have it on our table somewhere. We just got to find it. So where is it? First table, second table, third table? Where's f of 0?
The second table.
Yep, second table. It's right there. Look at that. We already did the work. So we can just simply write f of 0 equals -3. And since 0 was in the second part of our piecewise, that means we would have plugged it into that second part, the x squared minus 3, if we didn't have a graph, if we didn't graph it and make tables. Okay.
Wait, sorry. How did you get -3?
Right there. When I have 0 as my x, I get -3 as my y. Because remember, the 0 in here is representing our x.
It is in the second function.
All right. Last part, is it continuous?
No.
Exactly, not continuous. Because why? Why is it not continuous?
You have to lift up your pencil.
Yep. Yep, it's good for here. It's good like all this. It's good, right? This curvy part. But then I got to pick up my pencil to jump down here. So that's what makes it not continuous, that jump that I have to make to continue drawing it. Okay. All right, any other questions on the piecewise? No?
No.
All right. Whew, that one took a while, a little bit of time. Okay, let me go back to the review packet. So we're probably just gonna do a couple together because I want to make sure we hit some things before we go. So I want to make sure we talk about, where did the other one go? I want to talk about. Oh yeah, let's do 17. So let's at least do A, so we at least do one of them. So if my zeros are -2, 2, and 0 with a leading coefficient of 2, does anyone think they could write the function for this problem? Anyone want to take a stab at it?
I'll try.
Okay.
So f of x, would that be -4 and 2?
Well, we're going to start with our leading coefficient. That's why it's called the leading, goes in the front.
Oh, so that'd be 2?
So we're going to put a 2. And then we got to start filling in our zeros here.
And then that would be x, what would it be, like x plus 4?
Yep, good.
X minus 2. X minus 0.
Yep. Awesome. Which you can rewrite as just x. So I'll rewrite this so you can see the simplified form. The simplified form would be like this. Oh, hang on. iPad got funky on me. Okay. X plus 4 and x minus 2. That's the simplified form because x minus 0 is just x. So I just simplified it. Okay. Well, anyone want to take a stab at B?
We see what like on this 0 here. Here on B we have 0, -3, and -1. The factor is going to be x plus 3, x plus 1. So the second part with, I don't know how I can treat it.
It says and 2 has a multiplicity of 2. That's the next piece. that it says in the
Okay, with the multiplicity, okay, of 1. In this case, I think, I'm not sure about this one for the, I think is x plus 1 squared.
It says 2 has a multiplicity of 2. So we need another set of parentheses to represent the 2.
Maybe it's x minus 2
Huh?
squared.
Yep, good. And then it says leading coefficient is -2.
Yes, it's everything. It's it's like it's just f of minus 2 is a negative.
Put that -2 in front because that's our leading coefficient.
You mean okay? I want to go back a little, teacher. Here, when he said the multiplicity, can I say?
Multiplicity.
Yeah, thank you. Of 1, it's like and 2. Here it's I wanna write it as x minus 2 squared because it's multiplicity of 2.
2. Yep.
Sorry.
Yep. That's why we write it squared because the multiplicity is at 2.
Yes. Okay. Yeah, I wanted to.
Multiplicity of 1, we could write a 1 up here as exponents, but we traditionally don't write that in math. Usually we don't write like something to the first power.
Yeah.
Weird. Okay. All right. Any questions on these? Number 17. No. All right. So I'm going to do something a little different. And I'm going to go over to this homework, and there's a reason I'm doing it. I'm going to go over to this homework, and I want to look at these 2 problems. These 2 problems are not on your review, but you should probably go back and review them. Hint, hint, nudge, nudge. So let's talk about them. So the first one, what method would we use? The homework. Sorry, let me tell you which homework. It's homework 3.2. Roxwald 3.2.
So on number 3, one of the most common things is they didn't do the first thing, move that thing over first.
Yeah, I figured. Yeah. Yep. So what method would we use first of all? What are our 3 options? We learned 3 options. This was like day 1 of this unit. What are our 3 choices that we talked about?
Factoring, quadratic.
Yeah, factoring, quadratic formula, and
square root.
Okay, so which one is this?
Square root.
Square root. So square root. I don't remember what it was. Method, I think is what it's called. Method. Okay, so what would I do first?
Oh, property.
Okay, property method. Yeah.
Sorry.
Okay. What would I do first?
You'll move that 50, the -50 over.
Yes, if you don't move the 50 over, you can't take the square root of it. You're gonna make a mess on the left if you take the square root. You gotta move it over first before you can get rid of the squared. So you get x minus 2 squared equals 50. If you try to take the square root before that, really you're just gonna have a big disaster because you're gonna have all this stuff stuck under a square root and then you can't move anything out. So you can't take the square root until the squared part is alone. Okay. All right, what will we do next?
Square root.
Add the 2.
Okay, we're gonna square root, and then what do I need to write?
Minus square of 50.
Plus or minus.
Plus or minus, yes, don't forget
5.
that. And if it's a -50, what would I also have to think about?
The I.
The I.
Or the imaginary.
I.
Imaginary number.
Okay, so can we break down the 50?
Yeah.
50, 25, and 2, right? So what's that gonna turn into? I know we need to add the 2 still, but I just wanted to break this down.
It's 2i square 5.
Yeah, 5. 2.
Yep, because the couples get to go out, the 2 5s and the 2 stuck inside the house. Now you can add your 2 to both sides. This 2, to be specific. X equals 2 plus or minus 5 rad 2. There you go. Okay. Any questions on that one before we look at number 4? We have 3 minutes left. I want to at least start number 4. Okay. All right. So number 4, there was another one on another homework that was like this too. So you have 2 to go back and practice. I forget the other homework, but there was 2 of them that had this rectangular thing going on. So we have a rectangular swimming pool. The dimensions are already on there, 20 by 16. We have a concrete walkway around. And then the total area of the pool and the sidewalk is 780. So that means if I take this side and multiply it by this side, I should get 780. Right? All right. So let's get this. I'm going to fill this in just because it makes, oh, that looks awful. Let me try again. Hopefully that looks a little better. Okay. So I'm going to call this X just because X is just the easy traditional number. So that means that this sidewalk must be how wide also, even though my drawing's terrible. How wide is that part of the sidewalk? This part that I just drew?
X.
X, right? Okay. How wide is this part of the sidewalk?
Also X.
Okay. How wide is this part of the sidewalk?
Also X.
Also X. Okay. So let's try to write, oops, let me add that back in. Let's try to write the bigger rectangle now. Since I just said that the big length times the big width is what gives us the 780, that means I need the big width and the big length to get the 780, right? So tell me, how wide is this? See if anyone can figure it out. How wide is the whole big rectangle?
It's too wide, 2x.
We have a 20, right?
Then you
Of the number, okay.
So this piece, and this piece. So can anyone tell me how wide it is?
2 ones.
Would you say 20 plus 2x?
30?
Yep, exactly. 20 plus 2x. You can't say 30 because we don't know
Oh,
what the x's
right.
are. We don't know that they're 5, for example, right? So that whole side is 20 plus 2x, that whole side. Okay, can we also find the height of this? It's this piece, all plus this piece, plus this piece. So how tall is this?
16 plus 2x.
Exactly, 16 plus 2x. Now, I said at the beginning that if we multiply all of it together, we get 780 because it says that's the whole area of the pool and the walkway. So just to set this up, because I know we're not going to have time to solve it, and you all know how to do distribution now, I'm just going to help you set it up. We're going to multiply the 2 together, and that equals my, I'll write it in yellow since I'm over there, 780. That's how you set it up. That's how you get started. So you got to pay attention of, do I have the area of the whole thing or do I have the area of just the pool? Like, what are they giving me? If I have like a picture frame, do I have the area of just the picture or do I have the area of the whole picture and the frame? That makes a difference whether you add or subtract that X, right? That makes a difference. How you're going to relate that X to the inside versus the outside and what lengths you have. Okay. So you can go back and look at this homework, and there was another homework that had something like this too, because Professor Sievers graded this one and I graded another one that I know had something like this. So y'all have a couple to go back and look at. And I think they're in the homework too, like the textbook.
Yeah, I think the most common thing is that they subtracted the 2x or y'all started subtracting it. So I think we did something maybe in the lecture to where we had the larger one and we were trying to find the smaller one. But this one's the opposite way. We start with the smaller one and we're trying to find the larger one.
Yep. So that's why I said, try to draw your little pieces and think about, what are you identifying? Am I identifying the big piece or am I identifying the little piece? If I'm identifying the little piece, I might need to subtract off my sidewalks. If I'm identifying the whole thing, I might need to add my sidewalks on. Okay. All right, I know we're at time. So hope that helps. Go back and review these graded problems too, just to help you study. Don't forget quadratic formula. I know we didn't get to practice that today, and don't forget factoring, but that factoring's old, so y'all should be up to date on that anyways. But don't forget factoring and quadratic formula, even though we didn't get to those today.
Teacher, quick question about the number 2 in this review test, please.
Okay, Let me,
About-
well, we're out of time. Do you want to come back for office hours?
Yes, just quickly for 1 to
Okay.
2 minutes. Something like
All
that.
right, good luck studying, everyone. Don't forget to come in if you have questions. We're here on Zoom. If you have an issue, come talk to us.
Yeah, I'll be in at 11:30 like normal.
Okay.
Tomorrow?
Yeah. I always have office hours, even.
He has
testing.
office hours before, I have office hours after.
Oh, huh. I thought today was Thursday. Sorry.
No, it's not Thursday.
Sorry.
That's what I kept thinking. I kept thinking today's Thursday also.
I know, it's weird. All right, I'll be back.
Yeah,
for
have
sure.
a good one, everyone.
Yeah,
Wish me luck. I
right.
gotta